Hello and welcome to this tutorial. Alright, so now we are going to implement our artificial intelligence from scratch. We're going to code it line by line. And in this first code section, we're going to import the libraries. But before we start with this first code section, I would like to explain the connection between the AI and our map.py file. That is, why are we implementing this for the map? What is the purpose of our AI and where will we be using it? So it's actually very simple. We're only making our AI to select the right action at each time. So, okay, we import the DQN class from our AI file. So we will be making this DQN class in this file, but then we import it only to select the right action to play at each time. And we select this action exactly at this line. Action equals brain update, last reward, last signal. Last signal will be the input of the neural network. You know, it's composed of the three signals of the sensors plus the orientation and minus orientation. So that's the input, but then the output is the action to play, and that's only what we'll be taking from our AI file that we're about to make. So keep that in mind, it's very simple. We first import the DQN class from the AI, then we create the object brain from the DQN class, which takes as input the encoded vectors for the states of 5 dimensions, the 3 signals plus orientation plus minus orientation, the 3 actions go left, go straight, or go right, and then this gamma parameter. That's the only parameters of the DQN class that we will be making. And then, once we create that object, we select in the game class the action to play at each time. And that depends on the last reward and the last signal, which is the input. And that's all. That's the only purpose of making this AI. That's in order to have a real artificial intelligence playing the right actions at each time, the right move, instead of having random actions like we observed in the previous tutorial. Alright, so let's do this. Let's implement our artificial intelligence. And as we said, we're going to start by importing all the libraries that we'll be using to implement it. So that way we will have all the tools we need. Alright, so let's start with the first one. The first one is the inevitable, the NumPy library. The NumPy library, I always recommend to import it. It's the library which allows us to play and work with the arrays. And this NP here is just a shortcut, more convenient when we want to use NumPy. Alright, then the second library is random. So this is just because we will be taking some random samples from the different batches when implementing experience replay. So we have to import this random library as well. Then we will import OS. That will be just useful when we want to load the model, because once the model is ready, we will implement some code to save the model and then another code to load the model. That's when we want to, save the brain and load the brain whenever you want to shut down your computer and reuse the brain that was trained before for some new experiment. So that's important. Then we are going to import the torch library, essential. That's because we will be implementing our neural network with PyTorch, which I recommend much more than the other ones for artificial intelligence because it can handle dynamic graphs. So there we go with torch. Then from torch, we are going to import torch.nn. The NN module is the most essential one. That's the module that contains all the tools to implement some neural networks. And of course, there will be a deep neural network that will take as inputs the 3 signals of the 3 sensors plus orientation and minus orientation, and will return as output the action to play. Well, actually, it will return the Q values of the different actions, and using a softmax, we will return the action to play, only one, the most relevant one to accomplish the car's goal. So torch.nn, most essential one. Then we're going to give a shortcut to the functional package from, here we go, the functional package from the NN module. So this functional package contains the different functions that we use when implementing a neural network. So typically the loss function, we will be using the uber loss because that improves convergence, and the uber loss is contained in this functional submodule from the NN module. And since all this is pretty long, we're going to give it a shortcut and we're going to call it F, simply. Then only 3 modules to import left. So the next one is a another essential one, which is Optim, and we take it from still the Torch library and then Optim. There we go. And let's just call it Optim instead of torch.optim. So that's of course for the optimizer. We will be importing some optimizers to perform stochastic gradient descent. So we will definitely need it. And then we need to import AutoGrad, and that's only to take the variable class from AutoGrad. So the purpose of it is a little bit technical. Basically, we need to import the variable class to make some conversion from tensors, which are like more advanced arrays, to a variable that contains a gradient. So it's like we don't want to have only a tensor by itself. We want to put the tensor into a variable that will also contain a gradient. And to do this, we need to use the variable class to convert this tensor into a variable containing the tensor and the gradient. So that's a little bit technical, but that's what we have to do when working with PyTorch. And we do this thanks to the variable class. But before getting the variable class, we need to import torch.autograd. And let's give a shortcut as well, autograd. And then from torch.autograd, we import variable. There we go. And now we have all the libraries that we'll be using to implement our AI. So we won't bother importing any other library. We have all the tools we need, and now we're ready to create the architecture of the neural network. So that's exactly what we'll do in the next tutorial. And until then, enjoy AI.